properties. So one can be called reflexive closure, another is symmetric closure, another is transitive closure. So this is very simple, like, let me give you some example, then it will be clear. So one relation, let us just have an example like, say, relations are on the set A, and the set has something like, say, 1, 3, 5, 7, 9. So this is the set, and we will consider all the relations on this set. So one relation is R1, and you have some example pairs. Just I am taking something, say 1, 1, then 1, 3, then 1, 5, and 3, 3, then 3, 5, then 3, 7, and 5, 1, and 5, 7, and 7, 3, and 7, 5, and 7, 9. So these are the elements, or another one, 9, 9. Okay. So this is one example relation, and there are some specific pairs already given in the relation set. So this relation, is it reflexive? You can check the elements. So what you can say, is this reflexive? R1, can you check the relation?
No, sir, it's not reflexive.
It's not reflexive, so it is not reflexive. So the reflexive closure will come to make the relation as a reflexive relation. What are the elements missing? So what are the elements missing? So you will say reflexive closure of uh, the relation R1. The reflexive closure will be 3, 3, no, 3, 3 is given, 5, 5, 5, 5, and another missing 7, 7.
Seven, yes.
So you will consider the necessary pairs which will make the relation reflexive. That will be the reflexive closure. So reflexive closure actually is a set that will give you the necessary elements so that that particular property will be satisfied. So reflexive closure of R1 is 5, 5, and 7, 7. That's it. This is the set. Closure means the set of necessary elements. So I give another example, R2, and R2 is, say, uh, like this, and say, and writing something like this. Five. Okay, 5 5 is already given. So 7 3 and then 7 7 and then 7 5. Okay, no problem. 7 7 and another one. Say 9 1 and 9 5 and 9 9. Now, what do you think? What will be the reflexive closure of R2?
So there is no reflexive closure of R2.
So that means it is already a reflexive relation. It is
Yes.
already reflexive relation. So reflexive closure of R2 is null. There is nothing more needed. There is nothing more needed. So reflexive closure of R2 is null. So null means there is no element in that set. So it means the relation is already reflexive. So no more elements necessary. Is that okay? Is that clear?
Yes, sir.
Yes, sir.
So
Okay, so
the relations are made using A into A. Yeah.
yes,
And
in this
conditions based
case,
on A.
yes, in this case, relations are on the set A, and the set A is 13579. And what is the criteria? This is not given. So maybe there is a criteria. How can I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements in the R1 set? How can I get this? So there may be some criteria, but we do not know what is the criteria given. We can see directly the members. So fine. If I give you criteria in the question paper, then you will make the pairs. You will consider the pairs according to that criteria only, isn't it? So if I give you the direct pair, then fine, you will just see the things. If I give you criteria, say one criteria is, uh, something like, uh, so I'm writing here R3. Say one criteria is given like R3. This is this is x comma y pair, and the condition is, the criteria is x x is uh, x is, say what, say more, x is bigger, say x is greater. Okay, in this example, what else I can make? I do not know. Say just x is greater than y. So this is the criteria. Then you will think this logic. You will think this logic. So in that case, you can make the list if you want. That is possible. You will make the list everyone by writing, or you can consider the criteria given. So this is the criteria given, is greater than, that is the relation criteria. So is greater than is the relation criteria. You understand how the elements or pairs will be made. When the set is very, very big, when the set is not only 13579, this is the full set of natural numbers. It is the full set of integers. It is the full set of real numbers. So in that case, you cannot write all the elements. In that case, you will consider only the criteria in logical form. Logical form. So if you see this, then it is not reflexive. Sure, it is not reflexive because x is greater than x. That is not correct. So 1 is not greater than 1. So 1 is not a member. 1 is not a member. So in that case, 1 is not a member, so it is not reflexive, right? So the reflexive closure will be everyone. Reflexive closure will be everyone. So how can you say what is the reflexive closure? So you will write, okay, let me write this, then you will understand. In this example, the R3 example, you will write reflexive closure of R3. R3 is, there is a set and it will be x comma x, and you can write for all x in A. That means every x is missing here. Every x is missing here. So for every x comma x should be a member in the closure. You understand now?
Sir,
For the last example, I have written this. Yes, tell me.
sir, last line, I don't understand.
Okay, I'm explaining this thing again. So I have taken another example relation, that is R3. So this is my R3 relation. And in the R3 relation, what I have seen that there is no reflexive item, not a single one. Why not a single one? Because in the relation criteria it is given x is greater than y. So if you want to write the elements one by one, like this one and then this one and then this one and then this one, like every pair one after another, you have to follow the relation criteria. So can you take 1 comma 1?
No, sir.
Can you take 3 comma 3?
No, sir. Because here x is greater than.
So you cannot take any one. This is not a reflexive relation, and there is no x comma x kind of pair. No one is available. So 1 comma 1 is not here, 3 comma 3 is not here, 5 comma 5 is not here. So no one is here. So the closure relation, I mean closure reflexive relation will be everything. That will be everything should be included. So you will write, okay, x comma x for all. This is the for all symbol. So you can say for all, or you can write every x in the original set A. So whatever the element you have in A, maybe 1, maybe 3, maybe 5, maybe 7, for everyone you need this pair x comma x. So I have written this.
Okay, sir. Good.
You understand now, right? Okay,
Yes.
so this example I have shown because R1 and R2, they are the straight cut list of the elements, and R3, this is not a straight list of elements. This is a condition based relation. So in exam both can be given and you will write your answer logically. So it's up to you how can you write your answer. If you want to write the answer like, okay, I do not see 1 1, I do not see 3 3, I do not see 5 5, 7 7, 9 9, only the 5 elements missing. So you can write, okay, the reflexive closure of R3 is actually 1 1, comma 3 3, 3 3, comma 5 5, comma 7 7, and comma 9 9. So there are only 5 elements possible. You can write this and then I will give you full marks. This is also correct. Okay. But you need to know how to represent your answer logically. You need to know why. Because if the original set is very, very big, then what will happen? If you have uh, 1000 elements here, then you cannot write 1000 pairs. That is not possible. So both you should know. That is my point of discussion. Is that okay now?
Yes, sir.
Yes,
Sir,
sir.
Yes.
uh, the finding closure,
Hmm.
we don't need to depend on the condition given, do we?
No, the condition given or not given, you need to consider what is the relation given, right? So
Yes, sir.
if it is not reflexive, then you will check why not reflexive. What are the missing elements? So if R1 is given in this example, only R1, then you are not thinking about condition, right? You are not bothering about condition. Okay, whatever the condition, I do not care. These are the elements given, so I will see and then I will make my answer. Finish. If R3 is given, then only the condition given. So you will think about the condition and then you will think why it is not reflexive. What are the missing elements? Then you will understand or then you will find out, okay, these are the missing elements. So this is the reflexive closure. Okay. So based on the situation, actually, you will consider or you will make your answer. Maybe you will consider criteria, maybe not. It depends on the question, the situation. Any any more question? Is that
No,
okay? Or
sir.
okay. So let me go to the next topic, that is symmetric closure. The idea is same. Now you can understand easily that is the same thing. If it is not symmetric, then why not? What are the missing elements? I mean, what elements you could add so that the relation could be symmetric. So first you think about R1 and then R2, then R3, one by one. So think about R1. Is it symmetric relation? So you will think about 1 1 and opposite of 1 1 is the same thing. So don't worry about that. You think about 1 3. So 1 3 reverse 3 1. Is it here already?
No, sir.
No,
3,
sir.
No, sir, it's
3,
not.
3 1 is not present. So one thing you can check, yes, 1 3 is in the relation, but 3 1 is not present. So you can write, okay, symmetric closure of R1, uh, R1 is 1 or opposite of 1, 3, 3, 1, and then think about others. So do you have others as well? Say 1, 5, 1, 5. Do you
So we
have
have
Sir,
5,
five.
1?
5
Yes,
is
sir.
here.
We have 5 1.
So you have 5, 1. So it's fine. And 3, 5 and 5, 3.
No, sir, 5
No,
here.
sir.
5 is not here.
Okay, so 3, 5 is here. So opposite of this, 5, 3
5, 3.
is not present. So 5, 3 you write in the closure set. And then 3, 7 and 7, 3.
Yes,
Yes,
sir, 7, 3 is here.
it is available. So opposite is fine. And 5, 1, 1, 5 is already there. 5, 7, 7, 5. This is also present. 5, 7
Yes,
and
sir.
7, 5.
Yes, sir.
And 7, 9 and 9, 7.
Not
No,
here.
sir.
9,
9 7 is not present.
So you will write 9, 7. 7, 9 is already there. So opposite of that, 9, 7 should be.
9.
9, 7 should be. Then it will be symmetric. So it's fine. So these are the three items. These are the three elements you need to add so that the relation can be symmetric. That's all. So this is the symmetric closure of R1. So now you can think about symmetric closure of R2. What will be the symmetric closure of R2? What do you think? Do you need some elements to make R2 as a symmetric relation?
Yes, sir.
So what are the things?
Sir, for
Uh,
1 5, we need 5 1.
5, 1. 7, 3 is
Okay.
here.
7 3 is there. 5 5 is there. 9 5
9,
is
5.
there. 7 5 5 5 7.
So 5 1 and then
5 7.
5 7
Sir, 1 9.
and 1 9.
Yes, sir. That's it.
Okay, so that is it. So these are the elements in the symmetric closure of R2. And what you will write for the symmetric closure of R3?
Sir, yx for all xy.
Yes, actually in the same case again, X is greater than Y. So if you make it opposite, then Y is not greater than X. So in that case, you need everyone. You need everyone. So you can write, okay, you can write logically. You do not need to write uh, 1 3 opposite, so 3 1, and 1 5 opposite, so 5 1, and 1 7 opposite, so 7 1. So it's like that. Everyone you do not need to write. So what you will write, symmetric closure of R3, symmetric closure of R3 equal to, you will write, this is the set, you need y comma x, you need y comma x for every, you need y comma x for every x comma y, because no one is no one is available here. So it is not A, this is R3. So you can write in this way. Whatever whatever the pair you have in R3, whatever the pair means, 1 comma 3 is a, no, sorry, 1 comma 3 is not possible. 3 comma 1 is a pair. So opposite of that is needed. and 5 comma 1 is a pair, opposite of this needed. 5 comma 3 is a pair, opposite of this needed. So any pair what you already have in your R3, you need the opposite of that, because no one is present, everyone is missing. So in this case actually R3 is antisymmetric. R3 is antisymmetric. Is that okay? Do you understand this?
Yes, sir.
So this is the writing style. How you can write the R3 closure. Any more question?
No, sir.
Then let us talk a little about the transitive closure. Again, the same thing, the concept is same. So you will just consider the elements what you have, and then you will try to find out what you need. So in the transitive closure concept, you can write, okay, transitive closure concept, you consider R1 first. Again, in the same way, consider R1. So you will check the double pair first, then the third pair. So you will check the two consecutive pair first, then the third pair. So what will be the two consecutive pair first?
Sir, 1113.
Yes, possible. So if you consider 1113, then it will be 13. So
Yes, sir.
13 is already present. So in fact, 11 or 33 or 7755, this type of reflexive pair, if you consider, you will see it is present. Any reflexive 11 or 33 or 55 or 77, you will see it is present. So it is better to look for the different numbers like 13, 15, 35, 57, like that, so that you can exactly check whether it is transitive or not. So let us take two things. Say 1 3 1 3 and 1 3 and 3 5. Say 1 3 is 1, 3 5 is 2. So these are the two items. Then what you need?
So 1 5, which is present.
1 5 is present. Yes.
Yes, sir.
So if you take 1 3 3 5 as the two consecutive pairs, the third pair is 1 5 and it is present. So you are happy. Okay, fine. So it is good. Now think about others. Not only this one example. Now think about others. Say 1 3 and 3 7. So now I'm talking about 1 3 and 1 3 and 3 7. So what you need?
So
What?
1 7, and it's not present.
So 1 7 is not present. We need actually 1 7 to make this transitive. So we need 1 7. So we will write, okay, transitive closure of R1. It will be 1 7. This is one pair. Is it all or do you need more? Then you need to check.
More, sir.
So you need to check. So check it. So what else? 1 3, no more things. Okay, fine. So 1 5, then 5 1 1 1. It's fine already here. So 1557. Again the same thing coming. How? Say 15. I'm now talking about 15, and second item is 57. So 1557. We need 17. So 17 already included. Fine, done. And if you think what else? No more 5. Okay. So if you think about 3557, then what will happen? If you think about 35
So three
and
seven, it is present, sir.
Well, sir,
three
it's
seven
also
37 is present. Oh, okay, fine. So 37 is present. Then fine. 3557. Okay, let me just write it down. 35 and 57. We need 37. It is already here. So we
Uh,
are happy. We are happy. This is,
Sir,
yes.
there is one, sir. 3 5 and 5 1. We need 3 1, which is not present.
Yes. So another example, 35 and 51. So we need 31. So it is not available. So we will include this in the closure set. That is, we need 17 and also 31, right? And in the same way, you will look for others. So that will be the transitive closure of R1. So
sir. Seven
yes,
three seven 7335.
hmm.
Then
7.5.
775. Yes, sir.
7.5 is already here, so it's fine. And then let us think about others.
Three
Say,
five seven
So 377939 is not present. So that will work.
uh, what is that?
Three
What?
seven and 7 9. So we need 3 9, which is not present.
Okay, so you write 3.9, and 7.7 is also necessary. 7.7. Why? Because
Oh,
you have 7.7,
3 3 7.
7.5. What did I? Yes.
Yes, sir.
No, no.
7557 or 7337 goes
Yes.
up.
Where is 7.3? This one. So
Yep.
7.3 is one, and 3.7 is second. So you need 7.7. So I have written 7.7.
Okay, sir.
Okay. So in this way, uh, you can find out others. If there is any other, 7.999 is fine. And
Sir, it
maybe,
takes time. That's the thing.
yeah, it will take a little time because there are some elements here. So this is the transitive closure of R1. This is the transitive closure of R1. Now think about transitive closure of R3 and R2. So what will be transitive closure of R2? You understand what I have said or what we are discussing, right? So you can find it in the same way. It is time consuming but possible to find. Is that okay? Can you find out R2 also? The same technique you will apply, and
Yes,
you will look for different numbers, not the same number. If you think for 1133, then you will see that the third element is present. So think about other different numbers. Okay.
yes,
Say
it's one
1 5 and 5
Sir,
1.
five.
1559 95 is also present. No, no,
We
sir.
No,
don't need
not
9 5. We need 1 9.
Nine,
yes.
yes, sir.
You need
One
one
One.
9
line.
present.
So you will need one line. So this is one, and then maybe others also possible. Is that
Yes,
okay? Do you understand now?
Yes, sir.
So this is all. And what about R3? What you can write for R3? What is the transitive closure of R3?
So that will be difficult.
No, not difficult.
Sir, if we
It is
we only have
this.
x, y in the R3.
Yeah, so in R3, x is always greater than y. So x is always greater than y means 3 comma 1 or 5 comma 1, 5 comma 3 or 7 1 7 3 7 5 or 9 1 9 3 9 5 9 7. That's it. So if you think about two elements like say uh, say 7 comma 5 and another one 5 comma 3. So what do you think? Do you
2
have
comma
7?
3 will be present.
So then it will be x, y, z.
Yes,
Yes,
x
sir.
x comma y.
X comma y, then y comma z.
Yes,
Yes, sir. I
yes.
understand.
So
And y comma z.
y comma z.
Sir,
So what is the third element?
x comma z.
X comma z. So do don't you think the z x comma z is also available?
Yes,
Yes, sir.
sir.
Yes,
So,
sir.
sir, there will be no transitive closure.
Yeah. So there is actually no missing. There is no missing. Everyone is correct. So say you have 5 comma 3 and another item 3 comma 1 in R. So don't you think the third element 5 comma 3 is also in R? Sorry, 5 comma 1. Yes, 5 comma
Yes,
1, the
Yes,
third
sir.
one. This is this is also in the relation R. So fine. So there is no missing. There is no missing. So every time it will be transitive. Every time it will be correct, and this is a transitive relation. So in the closure you have nothing. In the closure you have nothing needed. This is the null set. In the closure actually you have nothing necessary. So that's it. Okay. So if you just write the transitive closure is null, then the result or answer is correct. But if you want to explain why it is null, how can you say this is null? So how can you explain this? How can you describe? Okay,
Sir, since x is greater than y and y is greater than z, it will
exactly,
obviously be greater than.
exactly. Yes, right. You are right. So you are
Yes, sir.
exactly correct. You will write in this way. You will write because because when when x comma y and y comma z both are in the relation, okay, we uh, we have, or we can say x is greater than y and also y is greater than z. So so x is greater than z. Therefore, or that is x comma z is also a member in R3. So in this way you can explain. So this is how you make your answer. This is the logical style of answer, logical presentation of your answer. And R1, R2, they are the just example. Okay. So I wanted to show you my slides, and it's not very, I mean, essential. It is okay. We don't have enough time. We have only 2 minutes. I thought this is the simple thing. I thought it would be finished by half an hour maximum. So I will finish the class early today. So it's not the reality. Anyway, so that is all for today. Do you have any question or anything to ask?
No, sir.
Sir, I
Uh,
do not have any question, but I want to share something.
yes.
Sir, the things you are doing like recording class and uploading, it's actually help us a lot
Mm.
because sometimes it may happen that we lost connection due to internet. In
Mhm.
fact, today it's happened, and I'm not understanding a lot of things, but I'm sure that when I'll recheck the video, I'll understand most of the things. So I would like to say thank you for these things.
Okay. You are welcome.
Yes, sir.
Okay. And
It's really
yeah,
helpful, sir.
yes, I understand. And I understand. And it needs a little extra work for me, but I love to do that. So it's okay.